All right. Okay. Well, I guess this is our last class before the final exam. Again, I will not have office hours next week. I had some office hours this morning, and a few of you guys came by. Um, we will. I'll just go over some more topics here in terms of review. We'll try some problems out, and I guess that's it. I'm still writing the exam, and I'll try to, when I'm done writing the exam, I'll post some topics, not a complete list, but maybe a short list of some of the topics that you should study. Um, and we'll go from there. I'm gauging about 25–30% of the exam will be, I would say, stuff from the first 3 tests, first, second, and third, and then the other heavy, the rest of the exam will be stuff covered in the 4th test and stuff after that. Okay, so a heavier emphasis on inference and hypothesis tests, confidence intervals, all of that stuff. Okay, so, but maybe about 30%-ish, 25–30% from the first few. Yes?
Is the cheat sheet we can bring just one page?
Yeah, I'm debating about the cheat sheet. I'll probably let you guys have more. Just make it open book, open notes. Well, we'll say 2 sheets front and back for your cheat sheets. Okay.
And are you going to give us the Z table and T table?
Maybe I'll have a couple extras. Okay. Don't count on that. It's more so like an emergency measure. So I'll have a few extra Z tables. I was thinking of bringing some, but I forgot to do it. So bring your own Z table and T table, or you can just photocopy a page out of the back of your book, and I'll have a few extras, but probably not enough for everyone. I think for grading purposes, there will probably be a larger multiple choice section, and that way it just helps get through the grading faster. And yeah, I'm still trying to figure things out. Okay, so yes.
Do you have the average from the last test yet?
The test 4 average was a 78. Okay. Test 4 average, yes. Okay. And at the end of the course, I'll probably do a little bit of curving. So I don't want to say anything yet. So I'll decide. I guess I have to decide who gets an A and a B and a C and who doesn't pass and things like that. But I'll probably do a bit of curving just so that I don't know, you guys get a little bit better grades than a strict 90%, 80% cutoffs. Okay. Yes.
What's your best suggestion or strategy for studying?
Best.
Like it's best to go over videos or practice problems?
I would probably emphasize, the homework problems that have been assigned. That'd probably be most relevant. Yeah, after I finish writing the exam, I'll post a list of topics that I think you guys should know, and use that as a guide for which homework problems to study, I would say.
You said it's going to be 70% of the 4th test and the stuff after that, and then 30% of the rest.
Rough guide there. Okay, so yeah, heavier emphasis on stuff. I don't even know. the inference stuff, the confidence intervals and hypothesis, proportions and means. That stuff. Okay. So heavier emphasis there. Some stuff from before. It's always a challenge to try to figure out the right length of the test so that it takes you about the right amount of time. I'm going to try to aim for 2 hours and 20 minutes ish as the average completion time. It's always a guessing game for me, right? Because when I take the test, I probably work, not to brag, but I probably work like 6 or 7 times faster than you guys, just because I know. Like, I've been teaching this like every day for the past X amount of years, so it's just, so I always try to guess. So probably if I finish in 25 minutes, that'll probably be about the right length of time for you guys. Okay. That's my guess. So okay.
Last question.
Yes.
Are the multiple choice going to be worth the same as previously, like as the other chapter problems, short answer?
Yes, still to be determined. I'm trying to write a fair exam that will test your knowledge and understanding of what we covered in this class, but it's kind of hard to do that, really. Okay, but anyway. All right, so let's we'll go over some more stuff. Let me try putting up a maybe a potential multiple choice problem, not exactly this. Okay, but let's say you performed a 2-sample t-test. T-test. Your resulting p-value is 0.03. If you performed a 2-sided test with alpha equal to 0.05, this means dot, 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 dot. All right, your answer choices are: you do not have evidence to support alternative. You have evidence to say the population means are different. You do not I'll let you guys think about that while I think of another problem. Do you guys need more time to think about this answer, or are we ready? Okay, what is our answer? B is the correct answer choice here. Okay, so here our p-value is 0.03. Is equal to 0.03, and that is less than 0.05, which is our alpha. So from this we know we are going to reject the null hypothesis and conclude that the alternative is true. We are performing a two-sample t-test, so the alternative is all about whether the population means are different, okay? So the alternative is going to be that mu1 minus mu2 doesn't equal 0, and so we're going to support that. And the only one that says we are going to support that is answer choice B, okay? And the other ones are just similar sounding but wrong, okay? So this would be akin to saying we're concluding that the null is true, which we never do. And this would say we don't have evidence to support the null, which we also don't do. Okay, and this would just be the opposite. If our p-value was over 0.05, then we would conclude A. But in our case, our p-value is less than 0.05, so we conclude B.
Can you expand on why C is wrong?
C is wrong because here is basically we're saying, what C is basically saying is do not accept the null hypothesis, or something like that. You do not have evidence to say that the population means are the same, which is what the null hypothesis would be saying, which is not, and we never say that's what we do. We either reject the null or we don't. We either support the alternative or we don't. We never say we're going to support the null or accept the null, and things like that. Okay? Alright, so I started writing up a problem over here. And it says you create a 95% confidence interval for P. Based on the interval, you conclude that the population proportion is different from a given value, say 0.15. If you use the same data, but this time make a 99% confidence interval, you would still conclude, these are your answer choices, still conclude that P is different from 0.15. Would no longer P is different from 0.15, or we cannot tell with the given information. What do you guys think about that? So again, these are not going to be the exact problems you see on the final, but they might be of similar thought process. Okay, you guys made your answer choice? What is it?
C.
C. We cannot tell what the information given. Okay? So in this case, our 95% confidence interval, all we know is that our confidence interval maybe 0.15 is outside of our confidence interval. Okay, so from the statement above, we just know that 0.15 is a value outside of our interval. Okay. A 99% confidence interval is wider. Okay, and so if I just tell you that 15% isn't within here, but I make this wider, it is suddenly possible that 15% is within the interval, but it's also possible that it's not. And you don't know because we don't know the exact values of our interval. Okay, so 99% is wider, okay, but we do not know if 15% is in the interval. Okay. However, if this problem had read, I make a 90% confidence interval, so same problem, but this part just changes to 90% confidence interval, what would we conclude?
Still conclude.
We would conclude A. Alright? So if we're reducing our confidence, the 90% confidence interval is more narrow than the 95% confidence interval. So at 95%, it did not have 15. If I make my interval more narrow, it will definitely also not have 15 within the interval. Yes, questions?
So in this problem, what does that 0.15 stand for? Is it p hat or the p hat, right?
It's not p hat. P hat is the your sample proportion. P hat is always going to be in the center of your interval, whatever you make. So 15% is just a given value, and you just want to know, based on your interval, is it different from some given value? We don't generally assign a letter to that. If we were to do a hypothesis test to see if our data indicates that it's different from 15%, then 15% would become P0. Okay, but for a confidence interval, you don't really make these hypotheses. Okay. Is that okay? Yes.
I understand it and I get the answer. What I don't understand is how we infer that the 0.15 is not in the confidence interval from the wording. The wording throws me off.
So it says, based on the interval, we are concluding that the population proportion is different from a given value of 0.15. And so,
Isn't that just saying that they're not the same, but it could still fall within the...
so here so first off, we're talking about proportions. And here we're only, because it's a confidence interval for P, we're only dealing with one sample. Okay, so yeah, maybe this will be a good opportunity just for a quick recap for our confidence intervals. Okay, we have confidence intervals for P, and that looks like P hat plus or minus Z star times standard error, which is P hat Q hat over N. And then we have a confidence interval, let's say for P1 minus P2, P hat 1 minus P hat 2 plus or minus Z star times the square root of P hat Q hat over N1 plus P hat Q hat over N2, where P p hat is equal to y1 plus y2 over n1 plus n2. And then we have a confidence interval for mu, which will be y bar plus or minus t star times s over the square root of n. And we have a confidence interval for mu1 minus mu2, which is y bar 1 minus y bar 2, plus or minus t star times the square root s1 squared over n1 plus s2 squared over n2. Okay, so for this, we say we are 90% confident, or whatever, I should just say blank, percent confident that P is between blank and blank. And the question we can answer is, based on the interval, do we have evidence that P is different from some value, okay? Maybe I'll stick in P0 there. I don't, not necessarily that, okay? But and then we see is this value within our interval or not, and that will provide our answer to whether or not we have evidence that P is different from P0. Okay, so if this value is within the interval, we don't have evidence. If this value is not contained in our interval, we do have evidence that P is different from this. Yes?
So P0 can be seen as some kind of prediction, right? Our prediction.
Yeah, kind of some given value, I guess, in the context of this confidence interval. I hesitate to use P0. I don't know if there's a symbol assigned to that. But yes.
So in the example you gave, 0.115 would be P0.
Yeah, 0.15, and we're asking, is 0.15 within the interval or not? If it's in the interval, we don't have evidence that P is different from 0.15. If 0.15 is outside of the interval, we do have evidence that it's different. Okay. Over here, we would say, you know, I am 90. We are, you know, blank percent confident that the proportion in group 1 is between blank percent higher, lower, blank and blank percent higher or lower than the proportion in group 2. Okay, so that could be something like, I'm 90% confident that the percentage of women who get their nails painted is between, I don't know, 50 percentage points and 60 percentage points higher than the percentage of men who get their nails painted. Okay? I don't know. Making these numbers up. So we're saying that we in that case, we have evidence that a greater percentage of women get their nails painted than men do. Yes?
So for these kind of statements, if the P0 is within the confidence interval, do we say that we have evidence that the P0 is? I mean, like, what statement can we make?
So, okay. So, so going back to this one, if P0 is in the interval, do not have evidence that P is different from P0. That's all you can say. You can't say we have evidence that P is P0 or P is similar to P0. All we're saying is that we don't have evidence that P is different from P0. Okay? Someone says, UCLA is 53% female. You go and take a sample, and your confidence interval says, well, UCLA could be anywhere from 48% to 54% female. Well, could it be 53%? Sure, it could be. We don't have evidence that it's different from 53%. At the same time, it doesn't prove that it is 53%. It's just, based on the sample we took, we can't refute this claim. That claim could be totally false, but based on the data we've collected, we can't refute it. That's what's going on.
So if it's out of interval, we say we have evidence.
Yeah,
of different things.
If we go and we take a sample, someone says UCLA is 53% female, and we take a sample and we're 95% confident that it's between 49 and 52% female, then we do have evidence that it's not 53% female. It could be 53% female, and our confidence interval or our data happen to lead us astray. That's a possibility, but we're 95% confident that our data didn't lead us astray. Okay. So on the other hand, if P0 is not in the interval, we do have evidence that P is different from P0. They're all similar sounding, and you can easily get confused, but sometimes even I get confused as I'm like, when people ask me questions, because I have to like listen, I have to focus so intently on what they are saying and what they're not saying. Okay. I guess I can make a summary sheet of this stuff. I'm making too many promises here. Yes?
So for the second case, you're accepting the alternative, that's what it is?
Oh gosh. Okay, so these are confidence intervals, so we don't have null and alternative hypotheses is the thing, okay? We can use our confidence interval as a way to make conclusions, but inherently the conclusions we make from a confidence interval is different from that of a, I mean, at the end of the day you're still going to say, I have evidence that it's different, or I don't have evidence that it's different. But I guess the perspective is, it's different, okay? With the confidence interval, you're basically saying, here's my data. Based on my data, these are plausible values for the parameter, and anything outside of that seems unreasonable to me, okay? With a hypothesis test, you're saying, if I assume this, then it's quite possible my data happens by random chance. So I have no reason to doubt my assumption. Or the hypothesis test could go, if I assume this, it seems extremely unlikely to observe my data. Therefore, my initial assumption is probably wrong. Okay? They're different perspectives on the relationship between the data and the conclusion you're making. Okay? All right. Should I keep going on this, or should I just? Yeah. What?
As for hypothesis testing,
Yes.
reject our null hypothesis, does that mean we support the alternative?
Yes, if you reject your null, you are supporting the alternative. Okay? If you, yes.
You have the evidence to reject the null hypothesis, and you have the evidence to support the
Yeah,
alternative.
the two are the same, okay? Rejecting the null is equivalent to accepting or supporting the alternative, okay? And not rejecting the null is equivalent to not having evidence to support the alternative, okay? But it's always you either reject or you don't reject the null. We never try to say we accept or support the null. I know. It's okay. All right. So going back to this over here, if 0 is in the interval, we do not have evidence that P1 is different from P2. Okay, so we don't have evidence that there's a difference between the proportions and the populations, the respective populations. On the other hand, if 0 is not in the interval, we do have evidence that P1 is different from P2. The conclusions for mu and mu1 minus mu2 are pretty much exactly the same. You're just going to replace the p's with mu's. Over there. Yes?
Are P1 and P2 the population parameters?
Yeah. P1 and P2 are population parameters, yes. They are the proportions in the respective populations. Okay, so let's try one out then. Okay, you take 2 samples. Okay, so sample 1 will be men, and you sampled 15 men, and I don't know, what are we measuring? We are measuring, I don't know, average IQ. Okay, so standard deviation. Okay, sample 2. Alright, so we'll make a confidence interval. For mu1 minus mu2. And what are the conclusions that we can make? Okay, so we do y bar 1 minus y bar 2. This is the center of our interval, plus or minus t star times two samples. When we're dealing with means, this is what we use for a confidence interval. 104 minus 101, plus or minus. So here I would use degrees of freedom equal to 15 plus 13 minus 1, 26 degrees of freedom. Now I need my table. 26 degrees of freedom 95% confidence.
Is it -1 or -2?
Oh, I'm sorry, -2, -2. I did the math right, but I wrote it incorrectly. "26 degrees of freedom, 95% confidence. The value I'm using is 2.056. Square root of 16 squared over 15 plus 18 squared over 13. So I have 3 plus or minus. Hope plus or minus 13.3. So the resulting interval goes from negative 10.3 to 16.3. So the correct interpretation here would be I am 95% confident that the mean IQ of all men is between 10.3 points lower and 16.3 points higher than the mean IQ of all women. Okay. So, do we have evidence that there's a difference between the mean IQ of men and the mean IQ of women? Not from our sample, okay? So we do not have evidence. That there is a difference between the mean IQ of men and the mean IQ of women. In this case, 0 is within the interval. And if I increase my confidence interval to 99%, we would still have the same conclusion that we don't have evidence that there's a difference. Man, time goes by quickly. All right. Let's see. So as for older topics, well, I'll finish writing the exam and I'll put up a list of maybe some of the older topics that you should know. Non-comprehensive, but I'll try to be fair in terms of what we've done. Yes? Oh, I'm sorry. Sample 2 I did not label. Would be the women. Okay. Alright, you guys. I guess that's it. So I'll see you guys on the day of the final. I hope this course has been worth your time and energies and effort. It's been a pleasure teaching you guys and having you guys as a class. So.
Thank you.